Hello everyone. We will do our next topic on very related topic to sourcing, but it is applied in the multi-criteria decision making environment where we end up having a situation when we have to manage more than one objective or when we have to accommodate multiple criteria. Okay, so goal programming is the technique sometimes where we have to manage multiple objectives, sometimes more than two objectives also. Okay, so this tool is and we have seen that while evaluating suppliers or selecting suppliers, right, there can be multiple criteria on which we have to assess the suppliers. So for example, we want to minimize the lead time or delivery time and we want to maximize the revenues. Okay, so these are two objectives which we want to address while doing our sourcing, right? Revenue means we will get, if we will get good quality products, right, we will have more revenues. Okay, so this kind of more than one objective might be there. So why goal programming and what is goal programming? We will see that this is the real life scenarios facing not one specific objective but collection of goals. So another thing is here we are not saying objective but we are saying goals. Okay, how this goal is different from objectives? So we will see down the line. So many a times the objectives are conflicting, right? So one objective might be like to maximize, another we would like to minimize. Okay, so a single solution is impossible to optimize conflicting objectives, right? So obviously if you will be having more than one objective, you will not get the optimal solution like we get in the single objective problem. Okay, so we have to compromise on solution base, like the solution space, and we have to arrive to how best we can accommodate, like what is the best trade-off we can get in satisfying the all objectives. Okay, so this is goal programming, right? So this is we need to we still be there in a linear environment, right, to solve the problem. So we try to solve multiple objectives, like as mentioned here, simultaneously minimize cost, maximize production and minimize labor, right? So what to use when we desire to achieve solution that is best? Okay, so see here we are not saying optimal, but it is best with respect to number of different criteria, right? So we need to select one criteria. So this can be the logic, we would see maybe we can select one criteria as primary and the remaining as secondary, right? We would solve for primary criteria, solve for the optimization, right? And the secondary criteria are treated as problem constraints by assigning some acceptable minimum or maximum values. This is the intuitive way of addressing such problems, right? So then we will get the acceptable levels to get the feasible solution. Okay, and then we can try. So we can have now the other objective as primary and keep rest of the objectives as secondary. So that means this is the intuitive thing we have to do when we need some tool which can accommodate multiple objectives. Now how goal programming would do that? So objectives are assigned target levels, right? The target levels, that's why they are called goals, not objectives. That means whatever objective we want to satisfy or want to achieve, we will give some target levels, right, which are called goals, right? And then all those objectives we will give some relative priority of achieving these levels. Okay, so these targets are treated as goals to aspire for, right? And these are not the absolute or the hard constraints, right? Like in typical linear programming optimization or operations research, basic operations research course, we have seen that constraints are mostly hard constraints, right? So what kind of thing can happen? Like here, x1 plus x2 is equal to 30. This is a real constraint. This is the hard constraint, right? But when we will treat this as a goal programming, so goal constraint, right? So achieving this thing exactly at 30 is not mandatory in the goal constraint. Okay, that means, you know, I can write the same constraint as this and as this. That means I can transform this objective not as a real or hard constraint, but I would say that this is the goal which I aspire to achieve. That means I might achieve, overachieve, I might underachieve, right? There can be some little bit leeway which is there in the goal programming. Okay, this just happens in, like, you know, our day to day buying also. If you want to buy a laptop, you would be having some price in mind which you would like to pay, right? But when you go to market, right, you would see many features, right? Many a times you will got to know some feature, like, you know, for which you are ready to compromise on price little bit, right? Or it might go other way around also, that, you know, because of some new feature or, like, you know, added feature, you know, the cost has come down because that feature, like, you know, now is driven from some very subsidized chip or something, so the costs have come down. So that it can happen both ways. Okay, so the same logic applies here. So goal programming, they, in place of real constraints, the constraints are transformed as goals, conditions one would like to achieve but are not mandatory. Now how we would transform these constraints to goal? So to establish a specific numeric goal for each of the objective, right? So now the objectives are treated. So when we would learn operations research basic course, we generally say that maximum z 4x1 plus 2x2, something like that. But now we will not have things like this. This equation can be treated as goal. That means we will specify a numeric goal here for each objective. Okay, so the goal, and but at the same time we have to formulate it in line with some optimization problem, right? So formulate an objective function for each objective. How one can do it? We would first transform it as a goal. We will say that 4x1 plus 2x2 has to have some goal, some target. It can be goal or you can say target. Okay, by having some leeway of underachievement or overachievement. Okay, seek a solution that minimize the weighted sum of deviations of this objective from their respective goals. Means this thing, you know, overachievement to this goal, underachievement to this goal are nothing but they are represented as deviations, right? So what we have done, we will transform each objective a kind of aspiring a goal, right? Formulate each objective, formulate then objective function for each objective. How we will do this, we will come to it quickly. So we will have some leeway, means leeway in terms of underachieving or overachieving this goal in terms of deviations, and we would use this deviations in the objective function, right, to see whether this goal we are targeting to overachieve or underachieve. Okay, now whatever I have said, how we are going to do that? Attempts to minimize the deviations between the desired goal and the realized results. What does this mean? So if in a real, in the real constraint, if the constraint is like this, right, or maybe it is just maximize x1 plus x2 first, and then I am saying that I am aspiring to have a goal here, goal of 30, but at the same time I might underachieve the goal. D1 superscript minus is underachieve, or I might overachieve this goal. This plus superscript says overachieve. Okay. When, under what condition this will be true? Isn't it? So, if we have to focus on this equation, this underachievement, isn't it? That means, first of all, if I am not clear of, like, I have multiple objectives, those can be transformed as goals. Now, we will see that, we will add overachievement and underachievement deviational variables in each goal objective. And now we would see that what do we want from this goal. Okay. If I would say that I want to underachieve the goal, that means this should be true. Correct? This should be true means I really want this deviational variable to be there, present in the goal, and this should go away. If this should go away, can I write an objective function minimize D1 plus? Because I want to aspire for goal in this manner. For every objective, we will transform into goal and we will write respective deviational variables for every goals, right? Now we would see what is our problem. Okay. For example, so first that we will have a positive deviational variable represents overachievement of goal. This is underachievement of goal, right? So if the desire is not to underachieve the goal, this should be driven to 0, right? How? We cannot make it 0, but we will try to minimize it. Similarly, if overachievement is driven to 0, that means overachievement of goal will not be realized. So what I have said is, right, can we see that? Let's say a very small situation where this is to decide that what amount of product A and product B be produced, right? One of the objectives is limit the amount of raw material consumed each week to 100 kg. This is my goal, right? So what I am saying is limit the amount. I am not saying it should be at least, I am not saying it should be at most. What I am saying is limit. That means this is a goal. Goal I want to achieve, right? So I can write that 7x1 plus 11x2 with deviational variables, right? And this is my goal. Okay. Now, though I have said limit, but limit, no doubt, it is not giving hard constraint of at least or at most, but what it is intending, at most, very close to at most. If it is at most, then what kind of problem we are trying to address? This one or this one? The first one, correct? If this is, that means we would represent this as a goal with our underachievement and overachievement. But if we want this goal to aspire for this condition, then which deviational variable should be minimized? This should be there or this should be minimized? This should be there. So then this should not be minimized. Which one should be minimized? This one, right? So I will write minimize D1 plus subject to 7x1 plus 11x2 plus d1 subscript minus d1 plus is equal to 100. Got it? Okay. So let me see. So suppose I have a1 x1 plus a2 x2. First, you should define it as a goal. Give some value, the goal, likely aspiring goal, let's say 1000. Correct? Add, deviational variables. Add deviational variable. Now see that where you want to aspire for. Okay. Now in many situation, I would say that I will try to have, this raw material close to 100. It should be as good as 100. If that is the goal I'm aspiring for, then what I would do, I would have both deviational variables in the minimize objective function. Okay? Yes or no? Is it? So this is the only difference. Like, we won't be focusing on the real constraints, but would be having goals. Okay. So this is clear that every objective function would be assigned a goal, right hand side goal, correct? Every objective function which we are saying, we would add deviational variable for each equation. That is clear, right? Now, given the situation, right, we will try to see which deviational variables in each equation should be minimized. Okay. Now, while doing it, there are two school of thoughts. One is that, we want this deviational variable and the next deviational variable to be minimized at equal priority. If it is equal priority, we will give 0.5 weights to both of them. If it is not equal priority, but I know this is more important than this thing, we can give 0.6, 0.4 and solve the problem, right? But many a times like, another school of thought is that, no, I don't want to give weights. They are very subjective. So in that situation, what they would do in that situation, right, we can go step by step. Take one objective at a time. Another constraints can be considered as a hard constraints, solve it. So first problem will be solved, we will get the solution, that solution we will consider as a constraint in the next problem while solving second objective. Okay. So this is how we would proceed. So based on our solution methodology, how we would proceed, the goal programming can be non-preemptive goal programming or preemptive goal programming. So non-preemptive goal programming is all goals are of roughly comparable importance. So this is weighted goal. We will assign weights to all the deviational variables, right, and solve it. You see here. Now Aij, Xj can be having multiple objectives, right, which have transformed into goals. Bi is goal, targets for each objective. For each equations, we will be having deviational variables, right? Like I can have 3x1 plus 4x2, d1 is equal to 40. Then I can have another goal 5x1 plus 6x2, d2 maybe 100. Okay. So this can be resources. Okay. One can be resources in terms of some raw material, another can be capacity of utilizing some particular equipment or machine or something. Okay, so this is one. So now how, based on probably for this problem I want to minimize this I want to minimize it. So I will write equation minimize W1 weight for this plus W2. Is it not like a linear programming problem where you want to minimize this deviational variables and this deviational variable, and you can now solve this in your solver. Okay, so you can have 0.5 into D1, 0.5 to D2. So these deviation variables are just the notional variables. Okay, so this is how you can either solve the problem with generalized goal programming. M is number of constraints. The system of equation represent goal constraints relating to the decision variables to the targets, right? So this is non-preemptive goal programming, right, which where you will be assigning weights. There can be a preemptive goal programming, right, is used when there are major differences in the importance of goals, right, where you would not like to give weights just like that. So then we list the goals in order of its importance. We begin by solely the most important goal, solve the problem by considering that goal only in the objective function, and next does the same for the second most important goal, keeping the answer of the first goal as a constraint in the second goal, and continue. How we can do is, for example, there is a company, one of the largest producer of power tools. The company is preparing to replace its current product line with the next generation of products. Now you see here, there are 3-4 goals they want to achieve. They want to achieve a total profit of 125 million. They want to maintain current employment to be 4,000, hold the capital investment down to more than 55 millions, right? I hope now it makes sense, right? These are the goals we have, right? So this is the unit contribution. Total profit from 1 to 3. What is this? ABC is the power tools. There are 3 new power tools ABC. Okay. So contribution of each power tool is given. Okay. And employment level, the capital investment. Okay. Now you see here, though these are the goals, achieve total profit of at least 124.5 million. So they are saying at least, then that means we want to satisfy this condition, but it is a goal. We are ready to compromise, but we would prefer to achieve this one. So we will write this equation, we will add, so we will write this equation goal 1 over goal underachievement D1 plus D1 minus D2 plus D2 minus D3, right? And now if we want to satisfy this condition, which one of them will go in the objective function? This will go or this will go? Underachievement goal, correct? So this will go in the objective function. If we are using non-preemptive, we will assign weights, like, you know, as if they have done the weighted goal programming. Okay, so what is the another preemptive thing we can do is, we will first minimize the first objective, most important objective, right, and then solve the problem. Second objective, but the results received from the first objective will become the constraint in the second problem, and so on. Third problem, by keeping the answers of first and second as a constraint, hard constraints in the subsequent problem. Okay, so the intention is not to get into so many details, but you know, you must have an idea how to solve this multi-objective problems. right, by using the goal programming and related variants of goal programming, right? Because I hope once you are able to formulate problems like this, you can easily solve in the solver, just like your basic linear programming optimization problem, right? The crux lies in how to form the formulation and how to accommodate multiple objectives, transform them into goals, and then try to solve it. Okay, so this is how. Now I'll quickly run through a real life application. The problem is to select the best supplier based on many goals: minimize supplier defect rate, rate of late order delivery, purchase cost, maximize supplier scores, after sales service level. Okay, so this is an automotive industry, you know, these are the members who are decision makers, and we want to have different set of measures, criteria, manufacturing, technology, business, service. So to get the weights, right, they have done AHP, they have used analytical hierarchy process, W1, W2, W3 for each goal. They have got the weights from AHP. This is a ranking has been done. Now the problem is here, they want to select the supplier, not only select the supplier, right, there are multiple products, and the decision is they can procure same product from more than one supplier, right? Now the situation is there can be multiple suppliers and multiple products, P1, P2, P3. Now these two products can be supplied from same supplier, or there can be two suppliers supplying same product, correct? If that is the case, what should be the quantity of P1, what should be the quantity of P2 supplied by supplier 1, what should be the quantity of P2 supplied by S2, quantity of P2 supplied by S3. How would you decide? Keeping in mind that the suppliers should meet all these goals, these targets which we have set. Okay, so this is where, you know, you see here 1, 2, 3, 4, 5 goals. We want to achieve 5 goals, right, by having this is multi-objective optimization problem, right? So we will use this binary variable, right? So we will not get into the complexity of formulation, but this is how, you know, each goal will be formed and other constraints will be formed. So this is the final output we will get, right? So this using goal programming, okay? So that means you see here material 1, product 1 would be, so material 1, these are the 6 suppliers, this is the purchasing cost, this thing. So this is the data we have. Material 1, what is the capability of supplier and what are the attributes? Supplier can supply product 1 at this cost, the order deliveries are this, defect rates are there, minimum or maximum order conditions, right? This is the solution, right? So one indicator is supplier, another is the material. This index one subscript is indexed for supplier, another is indexed for the material. So supplier 1 will supply material 1, this is the unit, supplier 1 will supplies 2, but see there are no 3, 4 which is supplying. So we know that which supplier would supply which material of what quantity. Okay, so this can be the result satisfying multiple objectives. Okay, so this is like, you know, I know it is difficult to now solve the problem, this is a complex problem, but you know, you are now being aware of, right, you have a tool which can help in solving multi-objective optimization problems. Okay, and you know the application you see now, you know, now we have done reverse auction. In the reverse auction platform, we can embed this tool, right? That when reverse auctions are happening, whatever prices and other features suppliers are, like, you know, bidding, immediately it can go to such tools, it can quickly churn out, right? If this is the case, this proportion should be go to this supplier. Okay, so this is how, you know, you have to do it. So any question on goal programming? Okay, transform your objective to goals which you want to aspire for. For each function, add deviational variable and try to see in which direction you want to aspire for that goal, means whether you want to minimize underachievement for each objective or overachievement of that objective. That particular deviation variable will go in the objective function of goal programming. Okay, and every time for every goal programming objective function, the objective function will always be minimization. Because we have to minimize those deviation variables which are not desirable. Okay, this is the observation here, right? So, and then just solve with your solver, right? So, this is the steps.